LeetCode. Problem 12, integer to Roman. Sounds like ancient history, but it's a sharp exercise in clean, structured logic. Real-world apps might still use Roman numerals for historical dashboards, finance tools, or localizations. The challenge? A limited symbol set, strict formatting, and no shortcuts. Let's ditch brute force and aim for something smarter, faster, cleaner, and easier to maintain. Okay, ducklings, time to splash into our first method, brute force. It's like hand carving each numeral with a chisel. Not elegant, but it'll show us how the pieces fit together. Let's build it out. We'll start with a string builder to collect our result as we break the number down from largest place to smallest. First up, thousands. For each 1,000, we drop an M into our builder and subtract 1,000 until we run out. Next, we check for 900, a subtractive form. If we see it, we toss in CM and shave off 900. Then we look for 500. If it fits, we add a single D and move on. After that comes 400, another subtractive combo, so we drop in CD and reduce by 400. Now we handle the remaining hundreds. For each 100 left, we tack on a C and subtract. Once we're below 100, we look for 90. That's XC, the subtractive shortcut for this range. If 90's gone, we check for 50. If it fits, we add L and take 50 off the total. Then we check for 40. That's another special case. We use XL instead of stacking 4 X's. Anything left in the tens gets converted by repeatedly adding X and subtracting 10. Now for 9. That's another subtractive case, so we plug in IX instead of repeating I. If a 9's done, 5 is next. We add a V and subtract 5. For 4, we again lean on subtractive notation, using IV instead of 4 I's. Whatever's left, we handle with plain is, one at a time, until we hit 0. Once we've built the full Roman numeral, we send it back as the final result. This runs in constant time, big O of 1, since we only check a fixed set of values and symbols. Space is constant too, just a growing string. It's a bit repetitive and hard-coded, but great for learning. No overflow worries here. We cap out at 3,999. A bit clunky, but solid for grasping the fundamentals. But repetition isn't efficient. What if we could just look up the right Roman string for each digit? Let's cut the clutter with a structured mapping approach. We'll define 4 arrays, one for each place value, thousands, hundreds, tens, and ones. These hold every possible Roman string from 0 to 9, including subtractive forms like IV and CM. Now to build our result, we grab the thousands digit by dividing by 1,000 and use it to fetch the correct Roman string. Next, we isolate the hundreds by removing thousands and dividing the remainder by 100. Then we fetch the corresponding string. Same idea for tens. Subtract the higher places, divide by 10, and grab the match from our tens array. Finally, we take the last digit using modulo 10 and pull its Roman form from the ones array. Time and space are still big O of 1, but now the code's leaner and less error-prone. Just 4 lookups. Even for 3,999, we're doing 4 clean steps. The trade-off? A little more space for the arrays, but for fixed input sizes, that's a smart trade in real systems. Let's push it further. Lookup arrays are cleaner, but still locked to 4 digits. To scale the logic and boost flexibility, we'll switch to a greedy approach using ordered value symbol pairs. First, we prep a list of numeric values and their Roman symbols, sorted from largest to smallest, so we always subtract the biggest possible chunk first. With that list ready, we set up a string builder to collect our final Roman numeral as we build it. Now we scan through the values top-down. If the current one fits, we subtract and append, repeating as needed before moving on. Inside that loop, for each value that still fits into our number, we subtract and append its symbol again and again, until it no longer fits. Once we've processed every symbol that applies, we finish up and return the full Roman numeral. This greedy method is also big O of 1 for time and space, but way more elegant. It processes just 13 symbols in a single predictable pass. FANG interviews love it for its clarity. Production code loves it for being easy to read and maintain. It's a feathered win. We kicked things off with brute force, clear but clunky, like chiseling stone. Then came lookup tables, structured and readable. But the crown jewel? The greedy strategy. It's simple, powerful, and scales beautifully. By scanning top-down and subtracting smartly, we wrote a solution that feels ready for real systems. Constant time, constant space, but with way more polish. This is the kind of logic top engineers bring to interviews and to the job. So keep thinking greedy and apply this mindset beyond Roman numerals. Level up your problem-solving game.